Hello, flat earth researchers, debaters, and debunkers. This illustration popped up in my social media feed, and it originally came with the question, which of these trucks are driving? So, of course, you can see from the illustrations of the trucks A, B, and C that the water and the air inside the trucks is being displaced differently depending on how the truck might be moving or not moving in some cases. So I thought this would be really good food for thought to add to the discussions that many level Earth researchers are having based on postulations and experiments that are being done by Dell from the YouTube channel Beyond the Imaginary Curve. I'll, of course, post links to some of Dell's latest experiments, which are basically showing that movement will cause the displacement of gases and liquids, as well as affect the upward or downward vector of masses within those mediums, whether they would usually go up because they are more buoyant or down because they are more dense than the medium they are in. Movement of the water in a bottle, for example, will stop that upward or downward motion of those masses within the liquid. So the way I understand it is what Dell is demonstrating with these experiments is that density and buoyancy is not enough to describe the layers of density that we have and the upward and downward vector we have in those different mediums on the Earth, and that you in fact need an external force such as movement to create these layers of density and the upward and downward vector. So then comes the postulation that is this upward and downward vector created by the Earth actually moving? And so we then have objects that are essentially decelerating because they are not moving through the air, but the Earth is coming up towards them instead. So I don't have any particular side on this issue, but I do have a slight bone of contention on the making that leap to the postulation. But at the same time, I understand that this is just a kind of exploration of our physical reality and seeing what we can then postulate from that based on what the real physics of the Earth that we find ourselves in. So kudos to anyone that's doing these experiments, and I think it's just great to have this avenue of exploration opened up. However, I don't personally think that these experiments can lead us to ultimately conclude that the Earth is moving. But then again, even in mainstream conventional science, just because of the way we describe the effects of gravity, you can indeed postulate that the Earth is moving up to meet the object instead of the object falling down to meet the Earth. Frankly, it works either way because all we ever have is a description of what's occurring in front of us. And then we can postulate that we would be outside of this reference frame that we normally have and how that would appear to us, or what is the true nature of the cause of up and down. Is it something mechanical? Is it something magnetic? Is it something electronic? Is it something else? Personally, I'm open to all of these, and I've got no problem with the discussion and these postulations because it does indeed at least let us open up our minds to all manner of possibilities. So again, great that these experiments are being done, and great that the discussion is out there, because then that allows us to move forward in some ways. And there's no doubt that what Dell is doing with the experiments to actually move the medium in a container will affect the displacement of the mediums and also affect the direction which things are traveling within those mediums. So as far as I'm concerned, that's all cool. But I think it would be good to have a clear distinction between movement and acceleration, and to make sure that those terms at least are fairly clear as far as what we're talking about, and whether we need to have further demonstrations or experiments that will help us discern between acceleration and constant movement. So that's really the only kind of bone of contention I have, and it's just because I'm having difficulty seeing that leap to the assumption that the Earth must be moving in order for this upward and downward vector to occur. But again, no problem with discussing this, and hopefully what we go through here will help clarify certain things and allow certain thought processes to continue. Of course, one of the first issues we face when doing experiments and then postulating whether they prove or disprove certain theories or assumptions about the nature of where we live is that we are bound by this normal gravity, for want of a better word, in which it doesn't matter what you assume the Earth to be, or whether it's a ball or a level plane, or whether it's moving or stationary. We are faced with this normal gravity in which a mass will have weight and it will have a downward direction in the medium of air or water, and a less dense mass, such as a helium balloon, will have an upward vector within those mediums. That is our reality, but of course we are limited by the experience and knowledge and the measurements that we can do, and being able to get out of that reference frame that we are in to really see what's happening. So in any case, we can only describe what we see, and we can measure certain effects, and we can recreate those effects as well. But we still cannot make that leap to assume that that is precisely what is happening in order to create the up and down that we experience. So we do end up going into kind of thought experiment areas based on having no gravity or no direction, movement or no movement. And so again, let's just try to get back to clarifying the difference between acceleration and movement or non-movement, and see if that makes a difference to what we can or cannot postulate from the demonstrable reality that we can experiment with. So let's have a look at these different ABC scenarios with normal gravity and the trucks going in this direction. Now, we could look at A, for example, and we would assume that the truck had been going in at a constant speed in a linear direction, and it's now decelerating, and so the more dense mass of water has now moved towards the front of the vehicle. And straight away we can choose different ways to describe the effects that we are seeing. You could talk about conservation of momentum, that the mass wants to carry on going in the direction it was going, or you can talk about inertia. The mass doesn't want to move, but regardless of how you want to actually describe it, what we do have is this displacement, because we have a change in speed. In this case, it's a slowing down, and this causes this displacement of the water going toward the front of the truck. And then if we could just skip to C, for example, what we can see there is that we would naturally assume that we have acceleration. So the truck is speeding up over a distance, and it's continuing to do so, or it's doing so in a short burst, and this creates this vector of the water, the more dense water being left behind or being forced to the back, of the container. Again, it really depends on how you want to describe it. And again, it might not really matter whether you consider the mass to be moving or being pushed. What we do see is this displacement when we have acceleration. So, of course, when it comes to B, we know that actually the truck could be stationary, and this would give us this horizontal layer of water on the bottom and air on the top, or it could be moving at a constant speed. Yeah, so we know, for example, that deceleration or acceleration will create a change, a displacement. But once a constant speed or a constant stop has been reached, then you'll get this horizontal equilibrium. Again, of course, we are in this environment where there is this downward vector anyway that would appear to pull or push everything down towards the bottom, with the more dense things being heavier and on the ground or on the surface, while less dense things are up from that. Okay, so we've got a whole bunch of different scenarios that are already presenting themselves, and postulations that we can make as to what's actually happening to the mass in the medium, what's causing the difference or the displacement of the masses in the medium. We could also assume that, for example, truck A is going downhill, and that would create this displacement. And likewise, we could assume that C is going uphill, and that would create that kind of displacement. And the truck B is on a level surface. But if we're talking about movement, then we know that B could be stationary, or it could be moving at a constant speed. Of course, any changes in that speed will create displacement, and bumps in the road and what have you will do all sorts of things as well. They'll make the water go in various directions as well. All right, so that's what we're dealing with there. So when it comes to thought experiments in which we imagine the same scenarios for the trucks A, B and C moving along in a linear direction but without normal gravity, this is where I experience a stumbling block, and I can't make that connection to the postulation that the Earth moving at a constant speed would give us this up and down vector or gravity in relationship to the direction that the Earth is going. And we can imagine various scenarios of being inside or outside a reference frame, whether we are moving, the reference frame is moving. Again, a lot of the time it doesn't make any difference, because this is the problem that I'm seeing, is that being stationary, as in truck B, or moving at a constant speed is the same. We can call it at rest, with or without normal gravity applied. If there is no change in the speed or change in the direction, then there is no displacement of the mediums, the less or more dense mediums, or the masses within those mediums. And so for me, I would see A, decelerating would create the liquid to be moving towards the front of the truck. In C, it's accelerating, so you would have an apparent movement of the water towards the back of the truck. Again, you can surmise that the water's moving or the truck's moving, one or the other or both, or one's being pushed and one isn't, one's staying there, one's moving. There's a whole different way, a bunch of ways that you can imagine it. But the way I imagine a stationary or constantly moving reference frame is that would not give us any particular direction for the displacement of masses, and we would end up with here, for example, a ball of water inside a container of gas. Now you could switch the scenario around, and you could have a bubble of air in a larger medium of water. Just as a side note, in my mind, the reason that a bubble or a ball of water would occur is because of the pressure of the medium around it. It's not necessarily forming a ball by itself. The air or the water is in a container, and that creates pressure around either the ball of water or the ball of air, and that's why it becomes that shape. But again, what's giving it the direction of up and down isn't satisfied by the postulation that it's moving at a constant speed. If, for example, you take the scenario of being in a train, you're sitting in your seat and, okay, you're being, if you like, pulled or pushed down by normal gravity. But if you are moving along in a linear direction, there is no directional gravity for you with or without the normal gravity. If you're moving forwards in the train at a constant speed, that doesn't send you to the back of the train just because it's moving forwards at a constant speed. That would only happen if the train accelerated, and then you would find yourself being shoved to the back of the train. Or if it decelerated, you would end up being thrown forwards. Again, what's actually happening? Are you being moved? Are you decelerating or accelerating? Depending on the reference frame, all sorts of postulations can be imagined from this scenario. However, in my mind, there should be, and I understand that there is a distinct difference based on my experience in the real world between acceleration and constant movement. Only acceleration will create a displacement of the mediums and the masses within them, or change the direction. So if you drop a bottle of water with things in it that are either going up or down, then you're accelerating the medium downwards, just taking advantage of normal gravity anyway. But it's a change in speed, it's a change in direction, whether it was at rest because it was or wasn't moving at a constant speed. When you drop something or you move it in any direction, you are accelerating it. But once things have reached a constant speed, in my mind, we have then eliminated any directional influence or any force or any external force that would send things in any given direction. So moving at a constant speed, in my mind, is the same as being stationary. And so that doesn't actually fit with the idea that an Earth moving at a constant speed would create weight for us. Only acceleration or deceleration would do that. And of course, what we can have is a centrifuge kind of situation in which everything is being thrown around in a circle, in which case that is like constant acceleration because you are constantly changing direction. So in a centrifuge situation, I would say that you would indeed get these layers of density and you would get this up and down vector caused by movement of the Earth, you could postulate. But moving at a constant speed, or a reference frame or a train or a truck moving at a constant speed, in my mind, doesn't create a directional vector. So it doesn't make sense to postulate that the Earth is moving at a constant speed, which is the same as being stationary, to say that that is what causes a directional vector, when a directional vector can only be achieved with acceleration. That's really how I want to summarize it and leave it, and just ask the question, should we be defining the difference between acceleration or deceleration and a constant movement as being the same? How do we approach this and get the correct terminology and make the correct postulations based on what we can measure in reality and how we describe it in reality? Thank you very much.